Alright, hi everybody. We're working through the Diploma prep material, and this is the chapter on trigonometry. This question here is giving me a point on the circumference of the unit circle. Okay, now that's important. When we're told that it's the unit circle, that is telling me something about the coordinates of that point there. It says then the point P lies in the terminal arm of an angle in standard position. What is that angle here? Well, okay, so here's the point on the unit circle. This is telling me something very, very specific because, well, sorry, two things I should say. First of all, I can tell because the x-coordinate is negative and that the y-coordinate is positive that this angle must be in quadrant 2. Okay, and so now here's my point up here on that unit circle. What's special about the unit circle here is that the coordinates of that point end up being the cosine of theta comma the sine of theta. Okay, so what this is actually giving me, what this point is giving me, is I know that the cosine of theta is going to equal negative 0.55919, or I could also say, in this case, it's also telling me that the sine of theta is equal to 0.82904. Now, the question is only asking me to solve for theta, and I'm given that theta is in the second quadrant here. It really doesn't matter which one of these things I use here. I'm going to use cosine, specifically because I want to talk about something specific that's going to come up here. So for me to figure out what the angle theta is, what I got to do first of all is figure out what my reference angle is. And remember, the reference angle over here is going to be the angle between the terminal arm and the x-axis. Okay, so it's going to be that angle right there. So to figure that out, I am going to perform the inverse cosine of positive 0.55919. Now, I'm doing this as a positive, and I want you to understand why I'm doing that. The negative here is telling me what quadrant that is going to be in, okay? And that's all it really is necessary for us to tell me what the quadrant is. Once I know the quadrant, I don't need the negative anymore, so I'm just going to do the inverse cosine of that value right there, and I get 56. Additionally, if I leave the negative in there, it's not going to give me that reference angle. It's going to give me an angle in the second quadrant. Now, in this case, that's exactly what I wanted. But if I was to leave the negative in there, let's say this was a sine function, that's actually going to give me a negative angle in the fourth quadrant. And tangent kind of does the same thing. So the calculators are programmed to deal with the negatives differently. And so you're better off just ignoring the negative, identifying what quadrant that means, and then getting the reference angle. Now that's 56 degrees as a reference angle in quadrant 2. So to get theta, I have to go 180 degrees minus 56 degrees, and that will give me 124 degrees. Is that right? Just want to make sure I double check, because I did that calculation wrong before. I just want to make sure I get that right there. Yeah, 124 degrees. There we go.